Hi, my name is Rob Martin and I'm a solution engineer with Robin Systems. And in this video we're going to demonstrate the process for installing and configuring Robin on GCP along with deployment of an application and then some various lifecycle management tasks associated with that application, specifically scaling up or out and snapshotting and performing thin clones of that application where you might want to share that application with other organizations within the enterprise. So to start, we go to the GCP console, log in, and the first thing we need to do is provision a couple of VM instances. Okay, so I want to create my first instance here. I'll start by giving it a name, specifying its shape. In this case, I'm just going to pick a moderately sized 8 vCPU, 30 gig RAM shape. For our boot disk, we're going to pick a custom image that we have here. In this particular project, it's a pre-built CentOS image called Robin v5 base. So I will choose that. And then under Identity and API Access, I want to be sure and select Allow Full Access to All Cloud APIs. And under Firewall, I need to select Allow HTTPS Traffic. We also need to add some extra disks to each of the nodes in the cluster. These are going to be raw disks with which Robin will build out the shared storage pool across the cluster. So we click on the disks submenu. These are going to be blank disks because Robin is going to be managing these disks. I'm going to choose delete disk just so that as I clean the environment up, I don't forget that those disks are hanging out there. So I have one defined, and I'll just define a couple more. Alright, so I have my 3 disks defined. And on the networking side, I need to add a couple of network tags. So first of all, I want to say allow service ports. What this will do is for any apps that we have in Robin that make use of port mapping, this will enable that. And it'll also enable port 9000, which is used by the console. The second tag I need to add is allow IP. So this will enable IP tunneling. For the Calico driver, Robin introduces into the stack here by way of the container network interface provided by Kubernetes. Robin has introduced a Calico overlay network driver, and so we need to enable IP traffic between the nodes because this is needed by that driver. Okay, and so I just want to double check all my various settings. Yeah, it looks like I'm good, and I'll click Create. Alright, so while that's creating, I'll just quickly provision my second instance. It doesn't have to be the same shape, but in this case I will make it so. I will need to pick the same OS image, and then just go through here and make sure all my various other settings are set consistently. Okay, I have my 3 disks defined. Let's get my network tags. Alright, just take a quick look, make sure everything looks good. It does, so click Create. Alright, so my first VM instance has finished provisioning. Let me grab that IP address and come over to the shell here where I'm gonna copy some files out to that newly provisioned VM, specifically the Robin images, the installer, and a few bundles that we'll use to deploy applications. Alright, so that'll take a few minutes. What I can actually do is do the same for the other VM instance. By the time I get this done, I'm sure it will be finished. Okay, so let me jump back over there, grab its IP address. Alright, so we'll go back over to the other one, see how far along we are. So it's going to take a couple more minutes to get all these files copied over. And then as soon as that is finished, we can begin with the installation of Robin on our first host in the cluster. What I can do here is go ahead and pull up another shell here, and let me grab that IP address again from the first server. Alright, so here I've actually logged in as root to our first VM instance, and this is the one where we will do the installation of Robin to start with. So this will be our master node, and then what we'll do is after we're finished here, then we'll install the agent on the second node. Let's see where we are. So we have completed with that copying of those files, so we're ready for the installation. So in order to do that, we will launch the installer. We specify the server option here, which says that this is going to be a master node. We'll give it a username for our super user, the password, and we'll specify a host type here, since in this case we're installing on GCP. We have a special GCP host type that we'll use. Okay, and it looks pretty good. So then we'll begin the installation on our first node in the cluster. Alright, so now that the installation of the master is complete on the first node in the cluster, we're ready to move on to installation of the agent on the second node. So let me flip back over to another shell here. Actually, first let me grab the IP address for that second node so we can SSH into it. Alright. Okay, and for this installation we'll run it slightly differently. In this case we're going to install the agent, right? And we also need to specify the IP address of the master. And so let me jump back over to the GCP console, and I need to grab the internal IP address because that's the only way we're going to be able to talk to that node inside of the cloud. Grab that IP address, and that's what we will specify here. Okay, and then from here we'll remain largely the same. We'll specify the username and the password. This is actually the username and the password for that super user we've already established on the master. So it obviously needs to match, and then we can't forget our host type. Okay, that looks about right. And launch that. So now that the agent installation is complete on the second node, we now essentially have a two-node cluster formed, but we haven't yet configured anything. So, and in fact, we can take a look at that configuration even before we finish, completely configuring it. We can go ahead and log in as our Robin user. We can do a Robin host list. And we can actually see the two nodes, and we can in fact see that one of them is the master. It's kind of hard to read this the way it is here, but this M designation over here essentially says that node 1 is our master, but that's really all it is. And then node 2 down here has no designation whatsoever, which means it hasn't been really fully defined yet. So that's what we want to do now. So let's actually go back over to the server, and it looks like I may have lost my connection there. It's okay. Let's jump over to the master. Get rid of this guy. Jump over to the master node again. Let me grab its IP address, because I can't seem to remember them. Okay, Robin login. Okay. And then now what we want to do is we want to actually define the roles for these nodes. It'd be one of the first things that we would generally do. So in this case, we're going to make both of our nodes in the cluster hybrid nodes, which means they will have both the compute role as well as the storage role. So for that, we want to do Robin host. Actually, first of all, before we do that, we actually need to define the fact that these two nodes are going to be participating in the same resource pool. So we want to say Robin host assign our pool. We want to first grab our node 1. And assign him to our default resource pool. And then let's do the same thing for our second node. Looks like I grabbed accidentally. Or no, I know what I did. I forgot to copy it. And ended up pasting the same one over. Okay, and now we're ready to actually assign roles to these both these guys. So we can go ahead and do node 1. Again, we'll make him a hybrid node. Okay, and let's do the same for node 2. All right, so now if we do a Robin host list, we can see a slightly different output. Now, not only do we see our master node here, node 1, but we can also see that it is of the compute and storage role, as well as node 2 also being assigned. If I can select these right, also being assigned both compute and storage roles. So both nodes hybrid. So of course we always have the option where we might have mixed nodes in the cluster. In other words, a node that might be compute heavy with light storage, and vice versa. We can, Robin supports a the notion of having compute only nodes and storage only nodes to allow both compute and storage to be individually scaled, right? So, but in this case, they're the same nodes, and just for simplicity, and particularly because we only have 2 nodes, we'll go ahead and leverage both across both nodes. Okay, so the only other thing we really need to do to complete the configuration is we need to define a file collection. So the file collection in Robin is essentially an internal store for Robin where various images, LXC images, bundles, anything that we upload to the Robin cluster, these are all stored in this mutually accessible file store by all the nodes in the cluster. So to do that, we will do Robin collection create. We will specify the node. Where is it? I'm trying to find. We first need to specify the size, and we'll just make it 20 gigs in size, and then specify the node whose storage will have let's see, default. Tell you what, I'm going to cheat, and I'm going to grab the syntax off of here. Okay. Replicas, of course. Okay, so now we are pretty much fully configured at this point, and we can do various other command line tasks, listing the fact that we just created that collection, for example. There's lots of different CLI commands that we can do. So so at this point, we can actually go and access the console. So let me pull up the browser, get back to the GCP console, and if I click on that guy, I can actually access the browser from either node in the cluster. Okay, and then we're brought to the Robin console at this point. So right now we don't have any bundles added, and that's what we'll do next. So why don't we'll go back to the command line, and let's list all our files here. And I want to add the Cassandra bundle. Okay. We'll give it a name. This is the name as it'll appear in the App Store interface within the console. Okay. We'll wait for that to upload, and I can go ahead and upload a couple others just to just for effect. And I can list these. Okay. So if we go back to the console, then we can see the three bundles that we just added. Okay. So now to deploy an application, it's really easy, right? So we'll just pick Cassandra in this case. And so what the user would do is come into the Robin console, click on the bundle, okay, and then from the manifest file, which is a YAML file that's part of that bundle, along with various hook scripts that are defined for the purpose of application-specific purposes around starting various services, for example, upon deployment, upon performing a snapshot type operation or cloning operation, perhaps quiescing various services in preparation for those types of operation. All those are built into the hook scripts that are again also part of that bundle. But the manifest file, actually, from that manifest file, we render this dialog for provisioning the application. And so I just want to give it a name. I'm just going to call it Cass app. Okay, and as also part of the bundle, the manifest, we've described all the various roles. Cassandra is a distributed application, so we're going to have seed nodes and member nodes as part of any Cassandra deployment. And so here we've got those nodes represented here, and for each one of those, we specify the compute, the memory, sizing, storage, etc. And so we can generally take these defaults as they've already been given by way of the manifest file. They can always be changed either in the manifest or any changes that are made here we can save off as a template to keep from having to continually come back here and make changes. We've got some placement rules here that can be specified, declaratively ensuring that certain components are perhaps co-located on the same nodes or conversely kept away from each other in the cluster. We can provide data locality specification, ensuring that data that might be frequently operated upon by a particular service is always kept locally attached to the physical node, or in this case the VM instance on which that process happens to be running. And so all these constraints can be declaratively provided here as these placement rules, which is among a variety of other things is part of Robin's unique value proposition. Okay, so once we have defined everything that we want to define here, then it's really just simply a matter of provisioning that application. So we can take a quick look at some of the things that are actually happening behind the scenes when provisioning this Cassandra cluster. In this case, incidentally, it's just going to have, there's just going to be a single, as we saw previously, a single seed node and a single member node. And in just a few more minutes, the rest of it will be fully up and running. We can take a look, generally when we issue operations like that, we can, under the Copilot, we can look at jobs that we've submitted. In this case, we can see the application create job that is still running. We're waiting on it. We can see all the sub-jobs underneath that, which some of which have completed, some of which are still executing. So obviously in this case we're waiting for the agent to report back that the member container has been fully provisioned. We go back to the dashboard. We can also see that we have containers that are currently in flight with regard to provisioning an application that's that's currently being provisioned. There's other things, of course, to be viewed in the console, which we can kind of maybe get to a little bit later. So it looks like the application has been provisioned, and so we can click on that. We can actually go down and click on the application itself, and we can actually see the containers that are running as part of that application. Okay. So now let's take a look at a couple of the lifecycle operations that are made possible with Robin. So if we take our Cassandra application here, and let's say we want to create a snapshot, either as a backup of the entire application stack in this case, or perhaps to share through cloning to be able to share the application with another organization within the company. So we just click on our management tab here. We could create a snapshot. We can give it a name optionally. I'm just going to take a default name, and this is a rather quick process. And then now we have a snapshot. We can actually take a look at this snapshot as a reference to see exactly what that configuration was at the time, because again, remember, the snapshots in Robin, as with the cloning, preserve the entire state of not just the data at the time the snapshot was taken, but it's a point in time consistent snap of the entire stack all the way up through the application configuration. So we can see here that this snapshot was taken at a time where there was one seed node, one member node, and with the amount of memory and compute that you see here associated with it at that time. So now let's see, what if we want to go back to the application, and let's say that we've had some users complaining about performance, and for our application we need to scale that up. So we have identified that the member node is in need of some perhaps additional compute, so we'll just add a core to that. Let's say we want to add some memory. Add a gig of RAM to that. And then from an I/O perspective, maybe we want to guarantee that in this case, and again, the quality of service management here is, from an IOPS perspective, is able to be managed on a per volume basis, right? On a per app basis, but down to a granular level of each volume associated with that container. So here we attempt to guarantee that in this case the commit log volume will get a minimum of these both read IOPS and write IOPS. We can do the same thing for the data volume. Maybe we amp this up a little bit and so forth. So then we can just apply that, and again we can expand this and see behind the scenes what the various steps are in doing this. All right. So it looks like our operation is finished, and of course at any time we can go and we can review the QoS settings for any of the containers. Here we can see the minimum read and write IOPS that we had established for the commit log volume, and we can see the same here for the data volume, and of course we can see our move from 1 CPU to 2 CPUs for that container. All right, so let's say over time there's been some various activity in the application. The data has evolved, changed, there's grown, what have you. Again, we can use this snapshot as the means for as a backup, right? As a means for being able to restore to a previous point in time. So for that, we can simply pull up the snapshot here and simply restore back to that point. All right, so we're finished with reverting the application back to the snapshot. And so now let's say what we want to do is we want to create a clone of this application to share with another organization. So from here we can basically use the snapshot as the basis for a thin clone. Give it a name. Say CAS app clone. We can make any changes we might want to around sizing of the seed and the member prior to deploying this. So we do have that flexibility. We also have another opportunity to play with the placement rules for this new deployment. But we'll just click clone. Okay, so what this will do is it will create an entirely new application, right? So this is an entirely new standalone application available, not just cloning the data, but cloning the data as well as a whole new stack to be able to be leveraged by, again, like we say, another organization within the enterprise. Okay, so we finished cloning the application, and we should now see we have a whole new application now that's been cloned off of that snapshot that we had created off the original. We can go back to the application screen and see that we now have 2 Cassandra apps. Okay, and obviously they're identical. Okay, so in addition to being able to scale up and scale down in terms of adding compute and memory per node, we can actually scale out as well. So let's take a look at doing that with our original Cassandra app deployment. Okay, and so let's say, for example, rather than looking at scaling up our member node, let's just add an additional member node. So we just simply come over here and click scale out, and we can scale out by adding 1, 2, 3, however many additional instances we might either need and or have cluster capacity to be able to support. So in this case, we'll just add 1. Okay, so we've finished the scale out operation, the screen refreshes, and then we can see our newly added member to our Cassandra cluster. So just to kind of wrap it up then, one more thing we might want to do, let's say for that clone, we shared with the other organization, let's say they just had temporary need for that application, and they have no more use for it. We can simply come in here and just to show you how easy it is to just delete applications as easily as they can be spun up. We'll delete the clone. And it's as simple as that. And we're left with the original Cassandra app that we had deployed initially. So that concludes the demonstration. If we kind of recap what we did, again, this was a ground up installation from the point where we need to provision infrastructure in GCP. So we started by provisioning a couple of VM instances, got them set up quickly, and proceeded to do the Robin installation on 2 nodes. So we built a 2-node cluster in Robin, and added a couple of bundles. We really only worked with the Cassandra bundle, but then deployed that Cassandra app. We showed how we can easily perform a variety of lifecycle management tasks like snapshotting, scaling up, restoring back to a previously taken snapshot, cloning, scaling out, and then finally showing how easily apps can be deleted. So that pretty much wraps it up. I hope this was helpful. It just kind of runs through high level, process for doing some of the basic, showing some of the basic capabilities of the Robin platform. And appreciate you watching.